So man, do I have a shortcut here. You're going to love this. You're going to love it. How did we come up with how did we come up with these asymptotes? Look, it was wherever sine was 0, it was undefined. Sine 0, undefined. Sine 0, undefined. For this one, wherever cosine was 0, I got undefined. Well, here then is a super smooth way for you guys to sketch the graph of secant and cosecant. You ready for this? Draw a dotted version, a real light dotted version of sine or cosine. And then put an asymptote on every x-intercept. Because an x-intercept is where y was 0, and then y being 0 ends up in the denominator, gives you an asymptote, right? Everywhere that, look, sine was 0 here. Well, look, that's an asymptote. And sine is 0 here. Look, that's an asymptote. Look, they're going to be x-intercepts here, but they end up being asymptotes down here. So, graph a dotted sine function and cosine function, which you should be getting real good at, and put an asymptote everywhere there's an x-intercept, because that 0 would end up being in the denominator. All right, put a point at every maximum and minimum. And then draw some parabola-looking curves, even though they're technically not parabolas. Okay, so use the above suggestion to sketch y equals the cosecant of x. Here we go. Y equals cosecant of x. You got to do a little memorizing to remember that's 1 over sine. So I'm going to draw a sine function. Starts at 0, ends at 0, 0 in the middle. It goes up to 1 first, it goes down to -1. So I'm going to do this dotted, right, because that's not the graph I'm trying to do. Go back here, it starts at 0, ends at 0, 0 in the middle, goes up to 1, goes down to -1. Here is 2 periods worth of the sine function. Now everywhere sine is 0, I'm going to get a vertical asymptote. So every x-intercept, you draw a vertical asymptote. And when it's sine in the denominator, it's always the zeros and the pi's. Pi, 2 pi, 3 pi. Okay, and then now I'm to number 3. Put a point at every maximum and a point at every minimum and draw your parabolas. Now, just so you know what's going on here, we just fed the dogs, and I think I hear them getting a little rowdy. I might have to take time out. I might have to play with a tennis ball or a wubba. I don't know. Okay, now over here, we got y equals the secant of x. Nope, that's not how you spell that. Secant of x, just about every time. Okay, so that's equal 1 over the cosine of x. All right, so 1 over the cosine of x. Everywhere that cosine of x is a 0 is going to be a vertical asymptote. So draw a cosine function. Put a 0 there. Sorry, it starts at a 1, it ends at a 1. There's a -1 in the middle. And we put zeros. All right, so there's 1 period's worth of the cosine function. Go backwards. It starts at 1, it ends at 1. There's a -1 in the middle, and this is how the cosine function is graphed. You got to be getting good at this. Now, I'm not looking to graph cosine. I'm looking to graph 1 over cosine, which is the secant function. And so everywhere there's a 0, you draw a horizontal asymptote. Sorry, vertical asymptote. Good. And then now we're going to put points at these maximums and minimums and draw our parabola-looking graph. So there's this one, and then there's one in between here going parabola opening down. This one opens up at that maximum. This one opens down at that minimum. And then this one, you only really get to do half of it because you kind of, you run out of picture. Otherwise, you could be drawing them all day. There's a quick way to draw cosecant and secant. So let me have you guys try these. Now that you got that idea, try and draw negative cosecant of x here. I'm going to tell you what to draw a negative sine function to start, and then just go from there. And then the secant of x, do everything that you did for the secant of x, and then every single point just moves up. The vertical asymptotes won't move. So go ahead and draw y equals negative cosecant of x, and y equals the secant of x, and then +1, which means it goes up 1. All right, do that now.